Good morning. How are you, girls? Today we want to start with a new chapter, chapter 30, Total Internal Reflection. Girls, this chapter is not new. It depends on the previous lessons, especially reflection and refraction. Let's start to see this lesson talks about what. Okay, the first thing we want to talk about is look at this image. Let's look together at this figure. What you can see two different mediums, glass and air. Now we know when any wave moves from a medium to another medium, what happens? Diffraction. We know this, okay? Because the speed changes and because of the density, different densities of the two medium. From glass to air, now we know that glass more dense and air less dense. What will happen? Look, the ray of light will refract away from the normal because it will speed up. That's good. What also we want to say, uh, in this case, when the angle is small, the angle of incidence is small, you will see two rays, one refracted ray and the other reflected ray. This case when the angle of incidence is small, okay? Which one is strong? For sure this one, the refracted ray is strong and a weak reflected ray, but we have them both, okay? Let's read this sentence or this paragraph to understand. When light passes at small angles of incidence from an optically dense to a less dense medium, such as from glass to air, there is a strong refracted ray and a weak ray reflected back into the denser medium. Okay? Is it clear? This is the first case. This is the normal case that we have. That only when it's moving from glass to air, from more dense to less dense medium. Increasing the angle of incidence increases the angle of refraction, and if you start to increase this angle, what will happen to the angle of refraction? Also, it will increase. We know that it will increase, okay? Because always the angle of refraction is greater than the angle of incidence, in this case, from glass to air. It will increase until what? Look, at a certain angle of incidence called the critical angle C, the angle of refraction is 90. Very good. So look here. You will start increasing the angle of incidence, increasing, and this one also will continue increasing. Increase the angle of refraction will increase until the refracted ray is on the surface and the boundary between glass and air. This angle, we call it critical angle. Here is it, look, critical angle C. At this angle, you will see the refracted rays on the surface or boundary between glass and air or any two mediums, okay? In this case, we will have a refracted ray. The angle of refraction here is what? 90 degree and a reflected ray. Okay? After that, now here's the angle of incidence, the critical angle. As we said, if you increase the angle more than the critical angle, in this case, you will not see refraction at all. You will not see any refracted ray. You will only see reflection. This case, we call it total internal reflection. Total internal reflection. Now, girls, you will be surprised. I know. You will say, teacher, how? We don't have here a mirror or a reflected surface. Yes, I know that. But this is the case. This is the case for total internal reflection. Okay? When do we have it? Two conditions we need for total internal reflection. Number one, the light must be going from a more dense medium towards a less dense one. So from more dense to less dense, from glass to air, from water to air, from glass to water only. If it is the opposite, you will not see the case for total internal reflection. Only you will see normal refraction. Okay? The second thing, that the angle of incidence must be greater than the critical angle for this medium. For example, The critical angle for glass and air is 42. Okay, we know this. It is always 42. It's fixed. The critical angle for glass air here. The critical angle, it's what? What does it mean? It's the angle of incidence, girls. The angle of incidence. This one is what? 42, the critical angle. So any angle more than 42, and if this ray it wants to move from glass to air with more than 42, the angle of incidence is 44, 45, 50. You will not see refraction, you will only see reflection, total internal reflection. Here, if the angle 45, total internal reflection, and the angle is 45. We don't have refraction. Okay, I hope that it's clear. Here, before we see the practical work, we have here simulation to understand more the concept. Look here, girls, please. Let's say that here I have glass and here I have air. From glass to air, more dense to less dense. This is the first condition. Now, let's see. Here is the light. I turned on the light. I want to move it. Now, at the beginning, here, let's say, at the beginning we said we have what? Small angles. Here, if I have the angle of incidence is small, what you can see? Angle of refraction or refracted ray and angle of refraction, and strong refracted ray and weak reflection ray. Okay, let's see. I will start increasing. Look, while I'm increasing the angle of incidence, what happens to the angle of refraction also? It's increasing. Look, I'm increasing until what? Here, at this moment, when you see the look here exactly. At this moment here, look, I can see this refracted ray, okay, and reflected ray. In this case, we call it critical angle. When we have the refracted ray with a 90-degree angle between it and the normal. Okay, I have a refracted ray and a reflected ray. Any angle more than this angle, what you will see only? Reflection. Look here, total internal reflection. So if you put a light from inside the glass, it will only reflect. You will not see refraction because the angle of incidence more than critical angle for this medium. Okay? Let's continue. Let's watch this video. Practical work, critical angle of glass. Look here. Glass. Source of light from here. So light enters glass. Then here we want to see what will happen to the light. Okay, from glass to air. Small angles, what you can see, look now. Refraction. Okay, small angle of incidence. So I have refraction. Look here what I have, a weak reflected ray. I have a weak reflected ray, a strong refracted ray. So now we didn't reach the critical angle. Look, I'm increasing the angle. Till now I didn't reach the critical angle because I still have what? Refraction here. Look. What happens now? More. I'm increasing the angle. Now look here. What do we call this angle? Critical angle, because the refracted ray now, where is it? It's exactly on the 90. Okay, this angle is the refracted angle. You record it. Now look what I have, total internal reflection, because I increased the angle more than the critical angle. I only have what? Total internal reflection. The angle here and this angle is the same. Now it's obeying the law of reflection. Okay.